Welcome, dear students, to a new chemistry session. At the end of this video, you will be able to apply stoichiometric calculation in chemical reactions. You need in this session a pen and your chemistry booklet. Let's remember some information together. A reactant mixture could be either a stoichiometric mixture or non-stoichiometric mixture. In a stoichiometric mixture, the reactants are totally consumed and converted to products at the end of the reaction. However, in a non-stoichiometric mixture, we have a limiting reactant and an excess reactant. The limiting reactant is totally consumed. It is called so since it limits the amount of products produced, and the reaction will stop when all the limiting reactant is consumed. However, the excess reactant is not totally consumed when the reaction stops. That's to say, a quantity of it remains at the end of the reaction. Let's solve an application together. Consider the equation for the reaction. 2C2H2 plus 5O2 gives 4CO2 plus 2H2O. Determine whether a mixture containing 4 mole of C2H2 and 10 mole of O2 is stoichiometric or not. First, how to determine whether a given reaction is stoichiometric or not? We find the ratios of the reactants and then we compare them. If the ratios are equal, then the mixture is a stoichiometric mixture. However, if the ratios are not equal, the mixture is non-stoichiometric. Let's find the ratios now. Ratio of C2H2 equal number of moles of C2H2 over 2 equal 4 over 2 equal 2. The ratio of O2 equal number of moles of O2 over 5 equal 10 over 5 equal 2. We notice that the ratios are equal. Then the mixture is a stoichiometric mixture. Let's determine in part 2 the mole composition of the reaction mixture when the reaction is over. What about the reactants when the reaction is over? In a stoichiometric mixture, the reactants are totally consumed, so their quantity at the end is 0. How to calculate the number of moles of the products produced? By applying stoichiometric ratios using the ratio of any reactant. Calculate the number of moles of CO2 produced first. By SR, we use the ratio of any reactant with the ratio of CO2 produced. By cross multiplication, we obtain the number of moles of CO2 produced. It is equal to number of moles of C2H2 reacted over 2 times 4 equal 8 mole. Let's calculate now the number of moles of H2O produced. By SR, we use the ratio of any reactant with the ratio of H2O produced. By simplification, we find the number of moles of H2O produced. It is equal to 4 moles. Let us consider the same example but a new mixture. We want to determine whether a mixture containing 1 mole of C2H2 and 3 moles of O2 is stoichiometric or not. Ratio of C2H2 equal number of moles of C2H2 over 2 equal 1 over 2 equal 0.5. Ratio of O2 equal number of moles of O2 over 5. 3 over 5 equals 0.6. We notice that the ratios are different, so this mixture is non-stoichiometric mixture. In part 2, We want to determine the mole composition of the reaction mixture when the reaction is over. Let's identify the limiting reactant. Ratio of C2H2 is less than the ratio of O2, then C2H2 is the limiting reactant. How to calculate the number of moles of the products produced and that of the excess remained? By stoichiometric ratios using the ratio of the limiting reactant. Let's calculate the number of moles of CO2 produced first. By SR, we take the ratio of the limiting reactant with the ratio of CO2 produced. By cross multiplication, we can find the number of moles of CO2 produced. It is equal to number of moles of C2H2 initial over 2 times 4 equal to mole. Now, we want to calculate the number of moles of H2O produced. By SR, we take the ratio of the limiting reactant with the ratio of H2O produced. By simplification, we notice that the ratio of H2O is 1 mole. Now, we want to calculate the number of moles of O2 reacted. By SR, we take the ratio of the limiting reactant with the ratio of O2 reacted. By cross multiplication, we find the ratio of NO2. It is equal to 2.5 moles. Let's deduce now the number of moles of the excess O2 remained. Number of moles of O2 remained, it is equal to number of moles of O2 total minus the number of moles of O2 reacted. It is equal to 3 mole minus 2.5 mole equals 0.5 mole. Dear students, you have this assignment. You have to solve questions 1, 2, 3 from worksheet 2 in your chemistry booklet. The molar masses of Fe is 56, for Cl it is 35.5, and for O it is 16. The chemical equation in exercise 3 is CaO plus 3C gives CaC2 plus CO. Thanks for listening.